G'day everyone, back here again for another lesson. This one's on parametric differentiation. Now, let's just backtrack a little bit, talk about parametric equations. The word para means to, metric means to measure. So when we're talking about anything that's parametric, well actually para means two or more, we're talking about multiple things and we're measuring them. So these two here, you can see as parametric equations because you've got y in terms of t, and x in terms of, let me update, x in terms of t. So the idea here is that we're measuring the y, so we're measuring this way, and the other one, x, we're measuring this way, but they're both in terms of time. Now oftentimes you don't want it in terms of time, or you don't want to know what's happening to this object in terms of time. You want it one in terms of the other. So you might want to find dy dx. Well, how do I do that? I don't have a function that is y in terms of x. Now you might say, well, why wouldn't we rearrange one, substitute it into the other, so that we can then differentiate it? Well, you could do that. And sometimes that is the easiest way to go. But let's look at another way. By the way, these graphs here were just to kind of give you an idea of what might this look like. It doesn't really matter. I just put them up there for a bit extra. So if I want to find dy dx, well, I'm not going to start there. I'm actually going to find dy dt. So if I find dy dt, well, that's pretty easy to find for me, because dy dt, just differentiate this with respect to t, it's going to be 4t. Done. Easy. Then what I can do is I can look here and I can say, well, okay, what's the derivative of that? Well, that's going to be dx dt. Okay, x with respect to t. And differentiating this, which remember that's going to be t to the minus 1, power out front, lower the power by 1, that's going to be minus 1 over t squared. So now I've got dy dt and dx dt. But again, I don't want any of them. But what I can do is I can recognise that dy dx is equal to dy dt times dt dx. And what that allows me to see is that these kind of cancel out like fractions, not really, but kind of. And then if this one, I'll bring that one in and put him in there. So that's going to be 4t. This one is not really the one I want. That's not really the one I want. I want to flip him upside down. I really want dt dx, which would be minus t squared. So then here I'm just going to put minus t squared and get my derivative of minus 4t cubed. So now I have dy dx in terms of t. Well, what are the key things here? Well, remember, parametric means para, many, metric to measure. Differentiation, well, that's pretty clear. We know what that is. Take your two functions, differentiate them separately, flip one upside down so that you can use the chain rule, and then you can end up at your derivative. That's really all it is in terms of doing these parametric differentiation. They do get harder depending upon what function is there and all of that, but really the concept is just that. Differentiate one, differentiate the other, flip one, multiply them together using chain rule, and I'm done. Hope this one helped. Let me know if you want examples of this. Catch you later.